Hello, my name is Darren Thomas. I am the Director of Educational Research Techniques. In this video, we're going to take a look at understanding some of the properties that take place when you graph sine and cosine. So let's go ahead and get started. So up here in the top, I have a table of different x values on the unit circle. So 0, pi over 6, pi over 4, pi over 2, 2 pi over 3, pi, etc. And then I have the corresponding value when you put these inside the sine function. So 0, 1/2, square root of 2 over 2, etc. Now, the reason that we're doing this is that if you take these values here and you graph them on a plane, you get this unique wave-like shape. And so let me see if I can draw this. Of course, this is not drawn to scale. We never draw to scale in these videos. But let me do a different color here, bring out the contrast a little bit more. It'll look something kind of like this. So it'll kind of go up, and then it'll go down, and negative, and then it'll kind of go up. And again, this is definitely not drawn to scale. And so what happens is that at the point where it crosses the x-axis is going to be right here at pi. And then that's not a really great color. Let me give you a little bit stronger difference here. There we go, pi. And then again at 2 pi. That's what's happening. Now, a few more things that we need to mention. I'm just going to draw a little two-dimensional plane right here off to the side. And you know, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now, get this. The positive values, these guys all right here, these are the corresponding values that you would have in quadrants 1 and quadrants 2 on the unit circle. And then the negative values down here below, we'll just give it a different color here. These negative values right here, this is what you would find on quadrants 3 and quadrants 4 of when you graph the unit circle. So in other words, it's kind of like, to make this as plain as possible, this is kind of like half the circle, kind of like this, when you're dealing with these two quadrants, and then you get the other half of the circle down here when you're dealing with this. So it's almost like you take the unit circle and you kind of bend it, and you get this little funny shape, S shape, you know, when you bend it like this, you know, from having it go like by changing kind of how the shape of it, but keeping the general principle of it. And that is what's happening when you graph the, what is this, the sine function, yes. So these are the corresponding y values, remember, that we will find on the unit circle. That's what we're trying to explain here. Now, one other thing that we need to talk about is this idea of the period. Notice how the period is when the shape of the function repeats itself. So this is what's happening. Kind of when you complete a circle here, you have a period. So the distance, let me see if I can make this as clear as possible. The distance from here all the way here is 1 period. All right? Now, so that distance is 2 pi. Okay? Now, what's happening is this. We start our journey here, and then we cross the x-axis right here. But that's not the end of the journey, because to complete the shape, if you will, or to complete the period, we have to be going in the same direction. So if we start going up and we go down, and then when we start going up, we're done. But here we're kind of halfway done. We're halfway, in other words, we've covered 2 quadrants because we've only done the positive values. To complete a period in this particular example, you must go through all the positive and all the negative values before you start to repeat yourself. So from here to here is kind of like half a period, and then I go down, and then when I get to 2 pi, I have a full period. And so now this right here is the beginning of a new period, going down, going up, all the way until you go off the screen. That's kind of what's happening. And so this is a way of looking at waves, if you will. And so this is when we start talking about stuff in like music and physics and all the other really cool things like that. Now, I've been focusing on the sine function, if you will, but I want to just kind of show you what the cosine function looks like. So here's the cosine function. Now, cosine is dealing with the x coordinates on the unit circle. So when I deal with this, you know, I got pi over 6, and then I get square root of 3 over 2, pi over 4, I get square root of 2 over 2, etc., like that. When you graph this, you start here at about 1, and then it's a little bit lazier looking, if you will, like that. Oh, let me give you a different color. Sorry about that. So a little bit lazier looking, and it kind of goes up, and then it kind of goes on like that forever. And the x-intercepts, if you will, if you want to call those that, would be pi over 2. And the next one is going to be at 3 pi. So when it comes back up, it's going to be 3 pi. 3 pi over 2. And so again, if you take 3 pi over 2 minus pi over 2, you get 2 pi again. You got the same value essentially. You get 2 pi over 2, which kind of goes to pi if you want. But you can see that this is how this behaves. And so these right here, just like last time, these will be the values from here to here. These will be the positive values, quadrant 1 and quadrant 2. Down here, these values down here will be quadrants 3 and quadrants 4. And when you have one whole journey of these two quadrants, you have a period like this. And that's what we've been talking about. So it goes down, then it goes up, and then it goes down. But this one is a little bit more different because we're kind of starting halfway here. And so this might not be the best example. Kind of actually the full thing is going to go over here. So that's not quite accurate probably for the period. But you get the general idea here. Now, one other thing that we need to mention is that the domain, the range, the domain is always going to be from negative infinity to infinity for both the cosine and sine function. This is the domain. And the range is going to always be between -1, and positive 1, if you will. That's the range. So it never goes beyond that. And again, that makes sense because, if you put one, if you're familiar with putting different values into sine and cosine functions, it never really goes beyond 1 or -1. Okay. Now, one other thing that I need to mention is that, let's see here. When talking about the period for the sine and cosine, it's a little bit different. I want to try to reiterate that before I move on. If you are dealing with cosine, it'll kind of look something like this. So you'll start at 1, and then you'll go down, then you'll go down to -1, then you'll come back up, then you'll go down, and then you'll go back down. Again, this is not drawn to scale, but this distance from here to here is a period, like so. And so you can see I kind of have half the journey here, then I have a whole journey here, and then I have another half journey. So this is kind of what's happening. This is what I should have kind of tried to explain earlier, like this. This is kind of my half a journey right here, if you will, because I don't have a full loop on either side. I have half a loop, and then a full loop down below, and that's how I got my period like that. So I know that's ugly, but I think you have the basic idea here. So let me see if I can kind of wrap up what I talked about and conclude this video. So in this video, we talked about graphing sine and cosine functions and how they make this wave-like pattern. And so you can see right here that when you put these x values into the sine function, you get out these corresponding values here. And then if you graph this, you get this nice little wave function like so. The positive values pertain to the first and second quadrants when you graph the unit circle on that two-dimensional space there. And then the negative values correspond to quadrants 3 and 4 when you graph the unit circle there. So the positive values and the negative values and that. When you complete that journey of going through all the positive and all the negative values, or in other words, when you go all the way through the circle and you go back to the beginning, if you will, you have completed one period. And so you can keep going and going and going and going, and then you'll just keep right on having this, keep right on having the circle, or not the circle, but the wave like that. So it's almost like the wave function is like you're taking the circle and kind of pulling it apart to make it a straight line almost, but it still has those curves because it is a circle. And then we talked about this also for cosine. The shape is slightly different, but the principle is the same. You have the waves, but you kind of have half a wave here when you start at a +1. Then you go down to the -1 and then back up. And so there's half a journey here, and then here, and then probably about right here is where the period is going to probably end at, right there. And so that's kind of how that works. So the domain for whether it's sine or cosine is -infinity to +infinity. That's for domain pertains to the x values, and the range is from -1 to +1. Oh, that's a typo right there. +1, and that pertains to the y values. And then just to make things clear, I tried to show you the domain here in the context and when you graph it on this two-dimensional space. If you start at +1, you kind of have half of the loop here, then you go down, you get a full loop, and then when you go back up here, half that loop, that'll be 1 period. So this is complicated a little bit, and it's kind of hard to get your mind around when you're just thinking about it, but I hope this is clear and it's trying to, make it easier for you to try to figure out what's happening here. So my name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.